So linear motion is simply the motion of something that is in a straight line. It can either be in the x, right, or in the y. So in the y, this is going to also result in 2 free fall. But in the x, well, that will just be linear motion. At times you can have an incline. When something is going up an incline or down an incline, that will still be linear motion because that is in a straight line. All right. But motion like this, motion in two dimension, this is no longer linear but projectile motion. So sometimes I want you to understand distance, velocity, acceleration, displacement. So if you talk about distance, I'm going to use an example to differentiate distance and displacement. Let's say I've got a point A and a point B. When you are moving from point A to point B, you might not be able to move in a straight line. So you might first go like this, you go like that. That might be because there are mountains, rivers, jungles, or something. And then you are going to reach at point B. So this road, the path that you have taken, is what you call distance. So what is distance? Distance is simply the length between 2 points. And it is measured in meters. So you don't care the direction in which you go, so it is a scalar. Now, the shortest path between 2 points, if you have a straight line from point A to point B, just a very, very straight line that connects these 2 points, this is what we refer to as displacement. So what is displacement? It is the shortest distance between 2 points. Of course, it is also measured. So it is also measured in what? In meters. Now the only difference is that for this one, which is a vector, it has got direction, all right? So we are going to show an arrow like that. Maybe east, west, north, south, like that. So displacement is a vector. Distance is a displacement. Now for both, you use the symbol S to represent them. Distance and displacement, both you use the symbol S. So when you say distance over time, which is S over time, this is going to give you speed. Now speed, we will not use S, we use V. Okay, same if you say displacement over time, you simply find velocity. So here you are talking of speed because you are using distance. Here you are talking about velocity because you are using displacement. Otherwise, you use this interchangeably. Distance and speed, you are going to be able to use them interchangeably. So let's say you have got a particle at position A, it has got a speed v1. And then at position B, as it is moving, it has a speed v2. You want to find the distance covered in a certain period of time t. So you know that from the equation, I'm going to write the equation that you already know from high school. What is the formula for speed? Speed, distance, and time. Who can remind us? What is the equation that relates speed, distance, and time? Florence. Abigail, what equation relates speed, distance, and time?
Speed is equal to distance over time.
Okay, speed is equal to distance over time, right? So v is equal to, that is speed, is equal to distance, which is s, over time, which is t. Now, if we want to find distance, we'll simply multiply these two. So distance is going to be equal to speed multiplied by time. Now, this speed you are using here is, look, you have got initial velocity, you have got final velocity. So which velocity are you going to use? And now I'm using them interchangeably, speed and velocity. So this speed you use is the average speed. So you are going to say distance is equal to initial speed plus final speed divided by 2, and then you multiply by time. So this you are able to see here is what we call average speed. Okay, so average speed times time, that will give you the distance covered between 2 points. Please guys, I need you to know this. You use average speed. This is very very important, because if you pick either the final or the initial, you use it in this equation, you're going to find the wrong answer. All right, I'm guessing that is okay. Now another thing that I want us to understand are travel graphs. Now when you're talking about travel graphs, you need to understand the distance time graph, the speed time graph, and the acceleration time graph. Let me start with the distance time graph. From what we know from high school, a distance time graph, what is going to be on the x-axis and what will be on the y-axis? Anyone?
Y will be distance, then X will be time.
Okay, so you always keep x as time. Whatsoever the time graph you are talking about, x should always be time. Always. So I'm going to put the three diagrams. Why have I put? So here you have got distance, here you have got time, distance, time, distance there, we have got time here. Now, when you have got motion like this, you have got something that goes like that, and then it comes like this, and then it comes like this. Now, this, remember, is distance, right? This is time. So this line, which is straight, this is going to represent speed. Okay, that is going to represent speed, and that is constant speed. All right, it is going to be constant because that is a straight line. And then here you are coming back, so you are reducing the speed. I hope you can see that. Right here you are moving at a constant speed, at a constant speed. Also here you are moving at a constant speed, but you are coming back. Here you were going at a constant speed. Here you are coming back at a constant speed. What do we mean by going and coming back? So let's say this x-axis is representing your initial position where you were. For example, this is your point A, right? So if you go, you are going to reach point B. Now, here you are no longer moving. That is why you can see there is a straight line. You are not moving. All right? You reached point B, but you are no longer moving. So what is happening here is you are at rest. So let's say this is point B, this is point C. So here you are at rest. So what you are able to see is that time is moving, but distance is constant. Even where I'm seated right now, time is moving, but I am not changing position. So if I wanted to draw the distance time graph of my motion as at now, it will look like BC. Okay, distance is not changing, but time is changing. Now, if you move, let's say, from C up to D, you are now coming back. You are coming back. You again, you see, you are coming from the same position. You are at this position. You are going back to this same position here. So this is coming back. You say coming back. This is going, and that is constant speed. Is that okay? Are we okay?
Yes.
All right. I hope we are. And then we can also have this. You have got motion going like this. Yes, all right. You can also have motion going like this. You can see this is looking like a quadratic, right? It looks like a quadratic. So this is constant acceleration. So acceleration is constant. If it is 2 meters per second, it is only 2 meters per second. It's not changing, all right? Here, when you have got constant speed, it means you don't have acceleration. So this one, which is showing constant speed, also means that acceleration is equal to 0. That's a meaning. Now here you don't have any motion. There is no speed. Speed is 0. Also acceleration is going to be 0. All right. Now this is representing constant acceleration, meaning that speed is changing when you have got constant acceleration, right? Then speed is changing. I hope we can get that. And then when you have got something like this, motion like this, here you have got a constant deceleration. It means you are reducing the speed. You can see you were moving very fast, you started moving slow, you started moving slow, you reach a point when it to be a straight line. And remember we said when you have got a straight line, then something is not moving for a distance time graph. Have I made it clear? Is this okay, friends? Florence, are we together?
Yes.
Okay. So this was for a distance time graph. Now let me remove distance here. I put velocity. Now I hope we know the terms to use. I hope we know the terms to use, friends. Let me put velocity here. I'm going to explain. So for velocity, let's say if we have got something like this, if you have got something like this, and let's say you have got also something like this. Now we have velocity here. Okay, so this one you can see we are only having the same velocity. If it is 10 meters per second, it is the same. So this one is representing constant velocity. It's different from a distance time graph. Constant velocity was going like this, right? This is constant velocity. If you have got constant velocity, what will be the value for acceleration? Abigail, if you have got constant velocity, acceleration is going to be equal to what? Martha, if you have got,
I think
okay, very good.
it will be zero.
Yes, constant speed means zero acceleration. Now, friends, this is for linear motion. This is an exam question also. They are going to ask. Okay, they are going to ask you how can you have constant velocity but you don't have zero acceleration? That's an exam question. So when you are changing direction, even if you are moving at constant speed, you are going to be having an acceleration. But in linear motion, when you have got constant speed, then acceleration is zero. And then when you have got this line, this is constant acceleration. And then if you have got this line, this is constant deceleration. Now deceleration is simply negative acceleration. And then if you have got this line for a distance time graph, for a speed time graph. Yes, Martha.
No, so why is it that line there? Why is it a constant acceleration? I thought it's increasing bit by bit as it's going. So
Yes,
I don't get how it's constant. Oh, it's constant acceleration.
yes,
Velocity. Okay.
yes. So the velocity is changing, but the acceleration is constant. So this one, you call it the linear change, okay? Linear change of velocity with time. Linear change of velocity with time is going to give you constant acceleration. This is an exam question. Linear change of velocity with time is going to give you constant acceleration. Now, this is a quadratic change. If you see a line like this, that is a quadratic change of velocity with time. Now, when you see this one, this is not linear motion, all right? Like, I mean, this is not constant accelerated motion. Okay, the acceleration here is not constant for this motion which you are able to see here. For a quadratic change of velocity with time, the acceleration is not going to be constant. Hope we have gotten that, friends. Now, let me just mention, if you have got a velocity, I mean acceleration, by the way, the area under a velocity time graph is going to give you distance. If you have got something like this, if you find this area using the formula, this is a trapezium, half a plus b multiplied by h. A is the distance from here to here, b is the distance from here to the end there, and then this is the height. That is going to give you the distance moved, the area under velocity time graph. Now, if this is an acceleration time graph, if this is acceleration, you have got a line like this. This is what is going to represent constant acceleration. So if this is constant acceleration, it means the speed is changing. That is for a acceleration time graph. That is what I want to you to take note of. Is that okay? Is that okay?
Can you repeat, sir? You said because it's an acceleration time graph, which means the speed is changing.
Yes, the only way that can be constant acceleration. For it to have constant acceleration, it means distance, I mean speed should be changing. Okay? I hope it's okay now. Now we
Yes, sir, pretty much.
okay, we need to know the three equations of motion. Like we need to know, friends, we need to know. The first one, it comes from acceleration is equal to final velocity minus initial velocity over time. So if we cross multiply, we are going to have final velocity minus initial velocity is equal to acceleration times time. I'll take the initial velocity this side. Then the final velocity is going to be equal to initial velocity plus acceleration times time. Now I'll basically write it as v is equal to u plus at. So this we need to know. We need to know this. Another equation that we need to know, we know that speed is distance over time. Now remember, when you are talking about, you can make also distance subject. Distance is speed times time. Now in physics, distance you use s, speed you use v. Okay, now when you are talking about distance, actually this velocity you are able to see is average velocity. So it will be initial velocity plus final velocity divided by 2, and then that value you have multiplied by time. Actually, because I've also included this, then the equations of motion are going to be 4. And then another one you need to know is that this uh, 2 distance times the acceleration is going to be final velocity squared minus initial velocity squared. This one also we need to know. And then again, distance is equal to ut plus half at squared. So these equations that you are able to see are going to change if you are talking about acceleration up or down. When you have got something moving up or down, where there is distance, you are going to put height. Where there is acceleration, you are going to put gravity, only for motion going up and down. Only. Okay. That is also, we can also refer to it as linear motion, though it becomes special, that is going to be free fall. Now, let's say you have got a building. This building is 20 meters high. and then you have got an object that is dropped. Please take note, you drop. Okay, you drop something from the top, and then it gets to 4 and reaches the bottom. You want to find the final velocity at the bottom. What will be the final velocity and what is the time it is going to take to hit the ground? So use one of those equations of motion so you can gather the data. Since you have dropped, that means that the initial speed is 0. The final speed you don't know. The time you also don't know, but you know the acceleration. The acceleration is what? 9.8 meters per second squared. It is always constant. So the acceleration is constant in free fall. It doesn't change. It is constant. And then you also have the height, which is 20 meters. So look for an equation if you want to find final velocity. So I can say 2gh is equal to v squared minus u squared. And this will give us 2. G, since we are going in the direction of gravity, gravity is going to be positive 9.8. And then the height is 20, right? And this is going to be equal to final velocity. That is what we want. The initial is 0, right? Because this thing is coming from rest. So we'll just get to multiply. First, 2 multiplied by 20, that is going to be 40. And then 40 multiplied by 9.8, this is going to be 392. And this is going to be v squared. So to remain with v, square root both sides, friends. So that is going to be the square root of 392. And this is going to give us 19.79898897,322. I can just write to one decimal place as 19.8 meters per second. That's the final velocity. And then if you want to calculate the time with which it is going to hit the ground, just say v is equal to u plus, instead of at, it becomes gt. Final velocity we've seen, that's 19.8. Now don't use a rounded off value. 19.798989. At least use even 4 decimal places. And that is going to be equal to initial velocity is 0 plus 9.8t. So just divide both sides by 9.8. So t is going to be 19.79 divided by 9.8. So this is going to give you 2.02 seconds. If you didn't want to use this, you could have used another equation. What equation could we have used? What equation do you think we are going to use?
S. Oh, yeah. S is equal to 8.
Okay, so the height is 20, right? And then this portion is going to be 0 because we are coming from rest. And then plus half, g is 9.8, and then t squared. So this will give us 20 is equal to half times 9.8, that will be 4.9, and then t squared. Divide both sides by 4.9, 20 over 4.9 is equal to t squared. So square root both sides. So I'm going to say 20 divided by 4.9. The answer that we get, square root that. So that is given me 2.02 seconds. So you see, whatsoever that you use, the answer will still be the same. Okay, imagine a footballer, after scoring, they are very happy. They get the ball, they kick it going up. They kick it with an initial speed of 18 meters per second. Now the first question, how far up are they going to reach? Okay, what is the height that they are going to cover? And also, what is the time it will take to reach the maximum height? So look again at the equations of motion. First, collect the data. The initial speed is 18. Now at this point, when you reach the very maximum, what will happen to the ball is that it will turn. Alright, the only way it can turn is that it has stopped moving. So the final position or the final velocity is 0. And then you don't know the time. You know gravity is always the same, 9.8 meters per second squared. Okay, so this is going to give you what? Then you are going to have 2gh is equal to v squared minus u squared. So this will be 2g is 9.8. Now notice that it will be negative. Martha, why is it negative?
because it's going not not it's because it's going up.
Okay, it's going in the opposite direction to the direction of the acceleration. And then final velocity is 0 minus initial velocity is 18 squared. So this is going to be negative 19.6 h. That is going to be negative 18 squared. Divide both sides by negative 19.6. So you notice that the negatives are going to cancel. So that will just be 18 squared divided by 19.6. This is going to give you 16.53 meters. That is how far you go. Let me just write this height down. 16.53 meters. Now I also want to find the time you are going to reach the maximum height. So V is equal to U plus GT. Find up, like you are going to see, they are going to ask you this question in the exam. They even give you 5 marks. Now look at this question. You just say v, since you are going up, it will be 0 the maximum, and then the initial speed is 18, and then gravity is going to be negative 9.8 t. Just take the 9.8, it becomes positive 9.8 t is equal to 18, and then divide both sides by the 9.8. So this is going to be 18 divided by 9.8, and then t is going to give you 1.8367. This is 5 marks. And I've seen other questions they've given for the same one, this one they've given 6 marks, and you start thinking, 6 marks with this short working like this. It is the correct thing. Okay, so it is not a matter of how many steps you take. It is a matter of if you know. That is why some questions are very simple, but they'll give a lot of marks. Are we okay so far? Are we okay? Hello, are we together?
Yes, our following.
Okay, let's say they've also told us to find the velocity. Okay, the velocity when this projectile has reached 10 meters. All right, 10 meters. So find the velocity. You see, it has got a maximum height h, but they say find the velocity and the time it is going to take to reach 10 meters from the beginning. So how can we work it out? So we can say h is equal to ut plus half gt squared. So let's find the time it will take to reach just 10 meters. So the height is what? Is 10. This is going to be, the initial speed is 18 multiplied by t. Gravity is negative, right? So that will change to negative, and then you have got t squared. Take this the other side. Now half multiplied by 9.8 is going to be 4.9 t squared. Take the 18 also the other side. It's going to be negative 18t, and then you have got a positive 10 that is going to be equal to 0. Use now the quadratic equation. T is equal to, Florence, what is the quadratic formula? Yes? Who can tell me the quadratic formula?
Minus b
Mhm.
plus or minus is equals to b squared minus 4ac over 2a.
Okay, divided by 2a. Now friends, make sure that this division reaches to the end here. If you cut it, it reaches here, friends. That's wrong. Actually, it's wrong. So we're going. This is a, the number in front of t squared, This is b, the number in front of t, and then c is the constant. So this is going to be negative. Now b is already negative 18, plus or minus the square root b squared, that is negative 18 squared, minus 4a. A is 4.9, and then c is 10, and then divided by 2 multiplied by a, which is 4.9. So I'm going to work out first this which is in this bracket. So we're going to find that t is going to be negative times negative 18, that will be positive 18, plus or minus. I'm going to work out what is inside. So that will be 18 squared minus 4 multiplied by 4.9 multiplied by 10, and then the answer that we get, we square root it. So this is giving me 11.313, and then divided by 2 times 4.9, that is 9.8. So that will give us t being equal to, I'll start with a plus. So I'm going to say 18 plus 11.313. Okay, 18 plus 11. The answer that I get, divide by 9.8. That is going to give us 2.99 seconds, or t is going to be, now we say 18 minus, that is 11.313. The answer I get, divided by 9.8, that is going to give us 0.682 seconds. Now friends, if they asked you to calculate the time it is going to take the projector to move from this point, go up and then come down, just find the time it takes the projector, not the projector but this motion or the object, to go up. The time it takes it to go up is the same time it will take it to come down. But we found that the time it will take it to go up is this one. So if you want to find the time it will take it to go up and then down, just multiply this value by 2. That is called the time of flight. The time of flight. Okay, the time it takes for the projectile to go up and then down, that's the time of flight. So this value, let's see what we get. 1.8367 multiplied by 2. This is going to give us, sorry, let me just do that again, 1.8367 times 2. That is going to give us 3.6734 seconds. So this is the time of flight. Now the question I want you to answer is that, why is it that we have found 2 times here? Yes, please, there's a question.
Yes, sir. I've said when you use this quadratic formula to find the time,
Yes.
this is the time for the whole total trip. How true is that? Or you multiply this times 2. I was told you only multiply time times 2 when you use the other formula.
Okay, so when we found this t, what we did is we said v is equal to u plus gt, and then we substituted v, final velocity as 0 on top, the initial speed as 18. That's when we found this one, just to reach to the top.
Oh, okay.
Yes. Now we, of course, we have used the formula, right? We have found that t is 2.9 and t is 0.6. Now what I want you guys to understand is, why if we find 2 values of time? Remember the question was saying find the time it would take for you to reach at what? At 10 meters. Now the thing is this, you are going to have t1, which it will take for you to reach this point here. This is going to be t1, right? And then the same 10 meters for you to reach there, you can also find it by first going up and then coming down. You reach here. This is going to give you t2. So when you add this time t2 and this time t1, it will give you the total time of flight. So that is why you are seeing that you found 2 values. Actually, this t you are able to see that is 2.99, and then this other one, this is the t1, which is 0.682, such that when you add those 2 values, you are supposed to find this value. Let's confirm if it is really true. 2.99 plus 0.682. So the time that I found after punching is 3.672 seconds. So you see, these are the same values. The difference, the last values difference is because of rounding. You see, you have got a lot of decimal points but are rounded off. So this is the thing. So if they've just said find the time going up, I saw an exam question which says, why have you found two values on the question? So the reason as to why you have found two values is because you have got the time when you are going up and the time found when you went up and then coming down. But it's still 10 meters of the motion covered. Are we good? Are we good?
Yes.
Okay. Now again, if they asked us to find the velocity, to find the velocity 10 meters up, let me just write there again because I've written the place. This, of course, the initial speed is 18 meters per second. This is all we've been told. And then they say find the velocity 10 meters from the beginning of the motion. Now, the velocity can also be the same. It can either be the one when you are going up or the one which you are when you are coming down. So because you have got one coming down and then another one going up, so you expect also to have two values of velocity, but they are supposed to be having opposite signs. The velocity itself is going to be the same because it's the same position but opposite signs. Why opposite signs? Because you are moving in opposite direction. So you can either go up and start coming down. So let's say if we can use 2gh is equal to v squared minus u squared. So this is going to be 2g is 9.8. All right, h, that is the height, we want to cover 10. Now we are going up, so expect this to be negative, right, because we are going up, and that is going to be equal to final velocity. We don't know the final velocity here, that's the one we want to determine, right, minus initial velocity is 18 squared. So if we say 2 times negative 9.8 times 10, this is going to be 2 times 9.8 is 19.6 times 10, that will be negative 196, and this is going to be v squared minus, let's say, 18 squared, that is a 324. So take this value the other side of the equation, it becomes positive 324 minus 196, that is going to be v squared. You see, if you use the wrong signs, you'll be finding negative things, and for a negative you don't have the square root. So 324 minus 196, this is 128, and this is v squared. So square root both sides. So the square root of 128, this is going to give us positive or negative 11.31 meters per second. Why have we found positive or negative? Because you can either just go up or go up and then start coming down. So this is it when we are getting to operate on some questions as this talking about linear motion and also free form motion. Now, another thing that I want you to realize, please take note, this is also very, very important. Imagine you have got, this is a building, huh? You get this object, you drop it. Now remember, you have dropped it. What is the initial speed when you drop something?
0.
The initial speed is 0. And then you have got another object, let's say this is object A, and then you have got another object B. Now this object, you throw it in this direction. Now you want to see which one of this is going to reach the ground first. So the thing is this, when you throw something horizontally, it doesn't have any velocity in the y direction, like it only has the x component of velocity, okay? The y component of velocity is 0 because you've thrown something horizontally. Now, since both objects have got the velocity in the y being 0, this object is going to move like this. This one will just come down straight. These two objects are going to hit the ground at the same time, at the exact same time. Okay? Because they are also going to hit the ground with the same velocity in the y direction. So they are going to hit the ground at the very same time. Please take note of that. Or the way they can also phrase this question is you have got a projectile. You throw a projectile going up. Yes, please.
Sir, I haven't heard. I was like, when you throw something horizontally, what happens?
So when you throw something horizontally, the initial velocity in the y is 0. It is just the same as something that you've dropped. So these two objects are going to reach the ground at the same time.
Okay.
And this is a question that they love bringing like in the exam. So they can also ask it like this. They can ask it like this. An object A has been thrown starting from rest at any angle. It can be any angle. When it reaches point A, immediately it reaches point A, another object B is released. Which object is going to hit the ground first? So now, since this one has been released, the initial velocity in the y is 0. And even this one, the only way it can change direction is that at this position, the velocity in the y is going to be 0. So both objects are going to reach the ground at the exact same time. Since the other object has been released when this one has just reached the maximum point where the velocity is 0. Or they will tell you you have got the hunter who is on a hill. Okay? The hunter who is on a hill aims at a monkey which is on a tree. Now, since they are on the same position, like this, now they are going to tell you the same time the hunter releases a bullet in the horizontal direction with a certain velocity. At the very same time he releases the bullet, the monkey starts to fall. Will the bullet hit the head of the monkey? So the thing is this. Since this one has been released with a velocity in the x, it means that the initial velocity in the y is 0. The monkey at the same time when this one has been released is also dropping. So the initial velocity in the y is also 0. Just give me a moment. All right. So in this kind of motion, in this kind of motion, at this point, since both have got an initial velocity of 0 in the y direction, when this one starts to fall, the same height which this one will fall is the same height which the bullet is also going to fall. So by the time this one reaches this position, the bullet would have also reached that position. And so the bullet is going to hit the head of the monkey if the hunter aimed at the head of the monkey. The thing is, they all have got initial velocity in the y as 0. And in the y direction, acceleration due to gravity is always the same, is constant. Since you are starting with the same initial velocity, you expect to have the same final velocity in the y. And so you expect to cover also the same height, since height only depends on the velocity in the y, initial and final, and also the gravity. So since all these are the same, then the height is also going to be the same. So if you are on a hill, you aim at something that is on a tree, immediately you fire, it starts to fall, you are going to hit it. So this is all application of free fall and laws of motion.